Hi, thank you for tuning into AskRose's live stream tonight. I'm Alex Gonzalez. I am a civil engineering major and I go to Rose-Hulman Institute of Technology, and today we will be covering some AP Calculus AB review. We started off on a different stream on Thursday covering different types of questions, and we ended off talking about the second part of the exam, which is part B, no calculator. And so we have some example problems that we want to go over just to get a sense of what it will be like on the AP exam. So for this question, it says if f is a continuous function on the interval -2 is less than or equal to x is less than or equal to 4, with the graph of f consisting of 4 segments, then let g be defined as g of x equals the integral of f of t dt from 0 to x. On what open interval is the graph of g concave down? State your reason. So this interval from -2, let's see, from -2 hold on, it seems that the tablet is not working, so 1 second. But for this problem, just to do a little bit of explaining while we fix up this part. For this problem, it is asking where in the graph of G is the graph concave down. And concave down means that in whatever direction that it is curving or trending towards downwards. So in this graph, since the pen died, so I have to charge it for like 2 seconds so it'll work again. So on this graph, this is not the graph of f of t, this is the graph of g of x, and the graph of g of x is for the integral of f of t. And so to find which is concave down, let's see if it connects again. There we go. -2 to 4. Okay. If you look at the graph without even considering the equation that we have over here, you can see that all of the sections of this graph, if we split it up into these 4 sections, they're all linear. They are not curved. So they are not trending towards increasing or decreasing in the slopes. So this part is going downwards. It is decreasing. But the trend for that slope is neither increasing nor decreasing. And it is the same for all of these. This one is decreasing, but it is not progressively decreasing at a larger rate or increasing at a larger rate than it is decreasing. The opposite is true for these, with the same result where they are going upwards, but they are not increasing upwards at a larger rate as you go from left to right, so it is not going concave up. Same is true for the last section, and they are not decreasing in how much they are increasing as you go from left to right, so they are not concave down. So nowhere in this graph is it concave down, because the slopes are constant. So let R be the function defined by R equals g of x times f of x. Find p prime of 2. I believe that's supposed to say R prime, but that's okay. We'll write that in right here. So if g of x, let me write this for my reference, is the integral from 0 to x of f of t dx, right? dt, my bad. Okay. this thing is not letting me turn. There we go. So if g of x is the integral from 0 to x of f of t of dt, and f of x is just f of x, and then that makes r of x equal to 0 to x f of t dt times and we want to find r prime of 2. So r prime would be, and we need to use chain rule for this, so we'll take the derivative of one side times the right side plus the left side times the derivative of the right side. And just filling that in, that gives us f of t, or f of x, since it is being evaluated from 0 to x, and then f, f of x, just the original, and then the left side, 0 to x of f of t with respect to t times so we'll use this graph that we have over here of g to find what each of these would be at 2. So r prime of 2 will be equal to f of 2 times f of 2 plus the integral of 0 to 2 of f of t with respect to t times f prime of 2. So to use this graph over here, if we know that this graph gives us the integral of our function f of x, then it is the area under the graph at f of x. So to find f of x is equal to g prime of x. And so we'll use this as we find the slope at this point to see what that is there. This is just itself times itself, so it's just f of 2 squared, and then for this side we will find where it is at 2, and then we will multiply by the last part. So for each component, slope at 2 is, see, rise over run, that's height of 2 and a distance of 1. So the slope here is 2. So r prime of 2 is 2 times 2 plus 0 times f prime of 2. And the beauty of this is that because you're multiplying by 0, you don't even have to find what f prime of 2 is, so you know that this is just equal to 4. So for part C of this problem, you want to find the limit as x approaches 2 of g of x over 2x squared minus 3x. So if we evaluate the denominator real quickly, 2 squared is 4 times 2 is 8 minus 3x, which will give you 6. So the denominator is 2. G of x at 2 is 0 right here. So you have the limit as x approaches 2 of g of x over 2x squared minus 3x gives you g of 2 over 2 times 2 squared minus 3 times 2, which ends up giving you 0 over the 2 that we had said before, which gives 0. For part D, find the average rate of change of g on the interval -2 to 4. Does the mean value theorem guarantee a value c on the interval of -2 is less than c is less than 4, for which g prime of c is equal to this average rate of change? Justify. So the mean value theorem has different conditions that you need in order to satisfy it. You need, so your interval is from A to B. A needs to be less than C, which is less than B, so that is satisfied. Oops. And F needs to be continuous on that interval. Well, there are no breaks between 2 and 4, so it is continuous, and it needs to be differentiable. There are derivatives that can be made out of every, let's see, from 1 and then 1 to 3 and then 3 to 4. So on each of these parts, it is differentiable on the open interval. So that means that it is continuous and differentiable. So if all of these conditions are met, then there is a number c such that f prime of c equals f of b minus f of a over b minus a. And you can fill those in accordingly to see what your c might be. Although the mean value theorem does not tell you what your c value is, but it does tell you that it is possible. So for this one, they want us to find g. So this is just what the mean value theorem says. For this problem, we want to see if this is true. So let's see, so for g of 4, we have 3 minus 4 over 4 plus 2, so we have -1 over 6. Guarantee a value for which, okay. So they want us to know if this value is equal to the average rate of change. So if we take the rate of change from the average rate of change from here to here and the average rate of change from here to here, then we want to know if that's equal to -1/6. If we look at the graph, just as a quick sanity check, that doesn't seem to be correct because your average slope for these 2 points would be this line. If you consider the slope of this line, then that might give you, oops, that's way too low. Let's erase that really quickly. So if you consider, oh my god. Sorry about that. So if you consider the average, it should give you the slope of the line from this point to this point. So we'll do the same thing we did earlier, except this time our rise for this is -1, and our run, our length, is 6. So it seems that our average actually is equal to -1/6, and the mean value theorem gives you an average rate of change, or the mean value theorem gives you a value for g prime of c that is equal to that. And so your average rate of change is equal to the rate of change that the mean value theorem says that you should get, which makes sense since it appeases all the conditions for that theorem. So for question number 5, given the function y equals f of x, whose curve is given by the equation 6y squared minus 12 equals y sine x for y is greater than 0, part A says show that dy dx equals y cosine x over 12y minus sine x. So really quickly, our equation is y sine of x, and they want us to find dy dx. So this is what they want us to find. So this one is just a matter of needing to do implicit differentiation, since you have both your variables need to be considered. It's not just a y equals equation. So you pop out a dy dx for this, since there is y, and then do 12y minus 12 is just minus 0 equals, and then we have to do the chain rule for this one. So you'd get dy dx sine of x plus y cosine of x. And notice we're only doing that for the y's because we want it to be differentiated in terms of x, and there is no such thing as dx over x, so we can leave our differentiation as that. We're going to move all of our dy terms to one side. I'm going to go ahead and pull the dy out and do 12y minus sine of x, and that just leaves the y cosine x. So we want to isolate the dy over dx by taking this side and shoving everything that we had on the other side in the denominator. So 12y minus sine of x. And this is the same thing as what we had up here that we were looking for. So we did what the question asked for. For part B, it says write an equation for the line tangent to the curve at point 0, root 6. So it's the same equation, but this time they want us to write the equation for a line. So the equation for a line, as I'm sure you know, is y minus y naught equals m. We're using point slope form, I believe is the name for this one, because they give you a point and you can find the slope by deriving that equation and finding what the slope would be at this point as well. So this is just the easiest way to do it. You can also do it in slope-intercept form or standard form or anything like that, but this is the one that will give you the equation for a line with the least amount of steps. So we can already go ahead and write that y minus root 6 is equal to m times x, and we just have to find m. So we have our dy dx, the slope, as what we found in the previous equation. So y cosine x times 12, and forgive me, I've already forgotten it, 12y minus sine x. Okay. We plug in our x's and our y's, and that gives us root 6 times cosine of 0 over 12 times, root 6 minus sine of 0. Cosine of 0 is 1, sine of 0 is 0, so that just gives us sine 6 over 12 sine 6, or root 6, sorry, our root 6. So those cancel out, and this leaves us with 1 over 12. We can plug that into our m that we had up there, and we have y minus root 6 equals 1/12 x. And that's your equation in point slope form. For part C, for 0 is less than or equal to x is less than or equal to pi, and y is greater than 0, find the coordinates of the point where the line tangent to the curve is horizontal. So this one is very similar to the one that we just did, except we have more constraints, and we know, find the coordinates of the point, and we know what the slope is, but we don't know the point. Okay, so for, oh, stop moving, where the line tangent to the curve is horizontal. So we know that our dy dx y cosine x 12y minus sine x, I remembered it this time. We know that this equals 0 because the line tangent to that is horizontal, so it has no slope. So our slope would be 0. And we want to find the coordinates in where that satisfies that line. So we want to find our y naught and our x naught. And this is 0, so this part is not particularly helpful, but it tells you how this problem is different from the previous part of the problem that we did, because in the previous part we could derive it, find what the slope is at a particular point, and then simply plug it into that equation. But this one, we know that it is horizontal, and we want to find where on the graph there is the point where the line tangent to that point is horizontal. Okay. So to do that, we have to consider what this graph might look like. So say it looks like this. We know that it'll be horizontal in one of these two types of points, meaning that it is changing from decreasing to increasing or increasing to decreasing. So to find one of those points, we could plug in numbers over here to find where that equals 0, but that's not going to be super helpful since we have two variables to consider. So what we do then is we have to find where it changes from a negative slope to a positive slope, or from a positive slope to a negative slope. So in order to do that, going to that's not helpful. Okay. So what we can do is we can make a number line and put in all the points where this could change from negative to positive. So we have to find the points in which this is equal to 0, which is what the problem is asking for anyways. So if x is going from 0 to pi, we could put 0 and pi on that number line and see what happens. So if we plug in 0 for this, we found that that gives us a negative slope. So we'll put the slope right here as negative. For pi, if we plug in pi, cosine of pi is 0, so that gives us 0 as our slope. So that should be one of our points that we consider. Yeah, so since y is non-zero, then we can consider only the numerator of this. And since this has our bounds of y is greater than 0, but not equal to it, then we can just consider cosine of x is 0 to find where on the x this could be 0. Okay. So on the points where cosine is 0, you can consider the unit circle. You have to consider where cosine, so where the x values are 0. So that's up here and down here. And for our purposes, that is, ignore this, that was wrong. That is pi over 2 and 3 pi over 2. And since x is supposed to be less than or equal to pi, that takes out this as a possibility. So find the coordinates of the point, as in 1, where the line tangent to the curve is horizontal. This has to be our x value because this is the only one that satisfies all of our constraints. So our x is pi over 2. Plug that into our top equation. We get 6y squared minus 12 equals y sine of pi over 2. This simplifies to 1, and we get this equation, which, let's see if this is factorable, because you can't use a calculator on this part. So typically they'll give you factorable equations to make your life easier, so you don't have to use the quadratic formula. Let's see. This is my favorite trick to see if you can factor an equation, is by seeing which groups of factors give you numbers that add together to get your b. So I don't believe so. Yeah, it looks like you might need to use the quadratic one. Okay, because your answers for where y is possible, and I wrote x's here, but I meant to write y's, gives you fractions. So the quadratic formula will give you that. It'll just take a few steps longer. And so what you would get for this is y equals 3/2 and negative 4/3. So you actually get 2 points out of this. No, you only get 1 point, sorry, because y has to be positive, so that automatically takes out this as a possibility. So your point is pi over 2, 3 over 2, and that is the point where the slope of the line tangent to the curve is 0, so it is horizontal. For part D, determine whether f has a relative minimum, a relative maximum, or neither at the point found in part C. Justify your answer. Determine whether f has it. Okay, so this is asking if that point that we found is one of these or one of these, as in one of the lowest points on the graph or one of the highest ones. So we can find this by seeing if this is a number line of the x values, and this is our pi over 2. If we do a little bit left of pi over 2, then our slope so our point is pi over 2, 3 over 2. So our slope dy dx is y cosine x over 12y minus sine of x. So if we choose a number that is to the left of pi over 2, like let's say 0, then we can plug that in, and from our previous portion, we know that that is negative 1 over 6, so that's a negative number. If we choose a number larger than pi, like let's say 3, we can plug that in and do, if this is 3, then that gives you so if you do a number larger than pi over 2, then you can plug that into this equation to find what your y would be, plug that into this equation, and it'll tell you that it is positive. So because it is going from decreasing to increasing, I'm going to assume it's going to look more like this one because it is a curve, then you know that it is a relative minimum. So because it is going from decreasing to increasing, it is a relative minimum. So for question 6, a medication is given to a patient. The amount in milligrams of medicine in a patient at time t hours is given by a function y equals z of t that satisfies the differential equation dy over dt equals 6 minus y over 2. At time t equals 0, there are 0 milligrams of medicine in the patient. A portion of the slope field for the differential equation is given. Sketch the solution curve through the point 0, 0. Okay, so they give us a point right here. A sketch of the solution curve. Okay, so given by a function of z of t that satisfies dy of dt equals 6 minus y over 2. So if we're going from here to any point to the right, for example, and you're increasing, then your line would have to look something like this, because your slope over here, no matter where you are on the x, is going in this direction, as the slope field tells you. So since you're going from 0, that tells you where you are starting, and these fields tell you in what general direction it should be going in. Yes, and you know that it can't actually reach 6. I know that my sketch says that you can, but because since the slope is now horizontal and there's nowhere on the slope field in the region that we have that tells you that it goes back down, then you have to assume that it continues to go horizontally. So for part B, using correct units, interpret the limit as t approaches infinity of 6t equal z of t equals 6 in the context of the problem. So they want us to interpret if t goes to infinity of z of t equals 6. So since z of t equals y, they're saying that y equals 6. In the context of the problem, okay, so essentially what they're saying is because dy dt equals 6 minus y over 2, then that causes a problem at t equals 6, because there z equals 6, even though we don't have an equation for what z of t is, we're supposed to assume that based on this slope field, that no matter what that equation is, no matter what all is going on there, is going to follow these trends, and that it is going to flatten out, that dy dt is going to flatten out at 6. So there's, at time t equals 0, there are 0 milligrams of medicine in the patient. So what this line is telling you is that at this time there are 0 milligrams of medicine in the patient. As time goes on, it is going to increase, except the rate at which it is increasing is going to decrease slowly until you get really close to 6, and then that is as much medicine as the patient will get. So the limit as t equals 0 of z of t in the context of the problem tells you that you can never reach 6, so there's an asymptote at 6. You can never reach that amount of medicine, but you can get closer and closer to it if you keep giving the patient medicine. And the units that it gives you are milligrams. If, for example, you started at a number that was greater than 0, like let's say you started at 4, you would still increase to 6. Likewise, if you started at 8, 10, or 12, for example, then you would be higher than that maximum. So eventually you would level off into 6. So in terms of medicine, maybe that tells you that the medicine is something that is given to them slowly or dissipates to a point where your body is content or stable at 6 milligrams. And you have to be sure to use the correct units in this problem when you are solving that limit, or else you will get points taken off. And so for part C, use separation of variables to find y equals z of t, the particular solution to the differential equation above with the initial condition z of 0 equals 0. I don't believe we have time for this one. However, this one, you have to consider the information that we found in the previous parts in order to justify your answer and kind of give you an idea on where to start. Because if you look at this graph, this can be used as a sanity check to see if your answer for what you get after the variable separation fits this model. And if not, that can be a way of checking to see if you maybe messed up somewhere. Yeah. So thank you for joining. The AskRose call center is open from now to 10 p.m. Eastern Time. Our next stream is coming Wednesday, where we will resume more of our algebra-focused content, and the best of luck on all your exams.